So for this one here, what we're going to do is just run through very quickly the calculator skills that you need to be able to do. So firstly, I expect that every person here can sketch a function in their calculator. That's the graph option. Make sure you hit the right X. Okay, so that's pretty basic. I'm pretty sure we've all got that. Once we sketch our function, it's really important that we can find intersections and intercepts. Now, intersections is dealing with what? One or many functions. Yep, so usually it's two functions, but the point where two functions meet each other. You need to be able to find points of intersection. You also need to be able to find intercepts. And the way we find intercepts, particularly x-intercepts on our calculator, is we look for when we go to GSolve, we're looking for that function root. Okay. Worst case scenario, we should be able to find those without our calculator, but it's a lot faster if you can use your calculator to find those. Particularly if it's just a extra part of the question that's not really about the, if it's an integration question, finding the intercepts isn't the maths that we're chasing at that point in time. Clear? Intersection points, GSolve, intersection. Happy with that? Also being aware that intersections and intercepts don't run by themselves. We often need to use that with our integration. If we're looking for physical area, what do we need to find? The area of both sections. How do you find the point where you need to break up your integration? Where it cuts the x-axis, which we call an intercept. Okay? So if you've got a function where you're looking for physical area and there's a negative and a positive section, we need to break it into two parts. And the way we find where we break it is by finding the x-intercept. Because everything below the x-intercept is going to give you what type of area? A negative area. Everything above the intercept is going to give you positive. Okay? Can every person in the room find the integration of a function or the area of a function? On your calculator. Go to graph. Get your function. Go to GSolve. I think you might have to go across. And you look for the little symbol that looks like that. You click that and you'll be given heaps of options. You can either go from intercepts or you can select a lower and upper bound. Okay, so you can select an area like that. So if you need... Thanks, Lockie. Every person in the room needs to be able to find an area using a bound. So using a point where you say like let x equal 2 and x equal 5. Be able to find an intersection point or find a point from, say, any point where it's positive. Sorry, if it's bound by the x-intercept, for example. So being very flexible in the way that we can find our integration on our calculator. Question 6, we literally just did this. So if you couldn't find the area between the two on your calculator, you need to be able to do that. If you're struggling with that, ask me. Same thing, graph, looking for little squiggly dx once we hit GSolve, and then if you go across to intersections, you should be able to select the point of intersection between the two functions. And lastly, well, the last main one is finding a probability using a z-score. For this one, we have to go to statistics. You need to calculate your z-score. It is very, very important that you leave mu as 0 and standard deviation as 1. Because if we're not doing that, we're not using our z-score. Are we clear?
If we were to change it, will it say in the question? Like if we get a question with mean average,
if you calculate a z-score, don't change it. Does that make sense? If you're calculating a z-score by changing these, you do the wrong thing.
Yeah, no, like the only time we change it is the question.
If the question tells you specifically not to use the z-score. Assume at any point in time with probability and normal distributions, you're calculating your z-score and going from there. In all the questions we've dealt with, we've been given a mean. And we've used our mean to calculate our z-score because z equals x minus mu over standard deviation. So you use your mean and your standard deviation to find your z-score. Cool?
But you can't always just put it in.
No.
Yeah.
Alright, and finally, being able to find our rate of change or our dy dx at a point in time. Sketch, G-solve, go for dy dx. You will need to put in a point where that occurs. Are we clear? Can you use your calculator to find the rate of change function?
Yes.
No, you need to show that you can do that. Can you use your calculator to algebraically and indefinitely solve an integration? No. You can use your calculator to find a z-score, but you're going to need to show your working about how you got there. Clear? Calculator skills can get you out of trouble. Use them as best you can, but make sure at all times we're showing communication and modelling and problem solving skills, identifying assumptions, etc., etc.
What would be an assumption?
It depends on the question.